You can take a break anytime you want to today. Yeah, so what was the vertex on that one we just did? 7.014.
Vertex was 0.210 and then the Y was 7.014.
Alright.
That's the maximum.
Good. Alright. That's the vertex, right?
Negative infinity.
So the range, of course, will be from negative infinity up to it. So the range would be, if I ask you for that, negative infinity up to 7.01 inclusive. I like it. What sucks is points look like intervals. Shit. Oh well, it's just something you got to be careful about. So that's a point, and that's an interval. Okay. So if you want to, you can try out number 11 right now. You know, make sure that you get the same answers as I do. I'm going to give you guys the answer key right now. See how I did. I think there's one of these I said in class, number 8. What's number 8 on the practice test? Is that one on the book?
Yes.
Which one?
889.
889, number
105.
Okay, good. That's the one I ask you. They give you a graph, and then I say, draw the inverse, right? Let's do that one right now. The rest of them are on there. Do you want these?
I have one.
You got one? That's your key? Okay. Let's see. So page 105, let me just recreate it up. Yeah. So I'm going to give you a problem like that. So I'm going to give you the graph, and you have to draw the inverse. Why does 105 have an inverse? If you don't have a book, let me draw it up here. Page 889, and they give us -4, -3. -4, -3, -2, 1, 3, 3, and 5, 6. They would do that to me. 5, 6. So it looks like this to start with. So F has the points -4, -3, -2, 1, 3, 3, and 5, 6. So how do I find the inverse? You're awesome. Yeah, just switch them around, -3, -4. For some reason, I don't care how much I say this, people change the signs. So that's the inverse can't do that. If it's positive, it stays positive, right? It's negative stays negative. So 1, -2, 3, 3. That's an easy one. 6, 5, and then you just plot that. And visually, you should know what to expect, because I might ask you something about why does it make sense. Why does your answer make sense? So -3, -4. 1, -2, 3, 3, and 6, 5. So when I graph this, why does the answer make sense?
Symmetric of X.
It looks like some kind of little insect. Symmetric with respect to
X equals
y equals x, yeah. Right, it's got that symmetry across the y equals x line. That's what I expect. If I switch the x and y, visually it switches over the y equals x line. Right, so there's a mirror right down there. Cool. But it would be better if I drew my scale consistent. So expect a problem like that. And like I said, that purple line, why do I know it's going to have an inverse? Why will that purple line definitely have an inverse? What's it have to do?
Horizontal line.
Yeah, horizontal line test. It passes the horizontal line test, so therefore it's 1 to 1. Therefore it does have an inverse. So just to show you an example, I think I said this before. If I have a parabola, I know I have to restrict its domain in order for it to have an inverse, right? If I try to draw the inverse, it would reflect across this. So this would turn down there, and this would turn around. It would go like this. Is that a function? No. So that's why, if it doesn't pass a horizontal line test, it has no inverse, because then the supposed inverse would not even be a function then. It would not pass the vertical line test. So don't forget, horizontal line test is just the vertical line test. But we go, why do I flip the freaking graph? Let me just flip the freaking test. So that's why we get a horizontal line test. Maybe. If I did flip it and then I apply the vertical line test, I go, oh shit, that's not a function. Well, let me just apply a horizontal line test to the original. So I don't have to flip the damn thing. That's where the horizontal line test comes from. All right, so now it's wide open. Whatever you guys want to look at. Yes, ma'am?
I have a question on 13.4, number 12. I don't know how to type that.
Oh, good. All right. This is sort of like one of the practice test problems. So normally, in these work problems, they tell me, Frank can do it in 3 hours, and Rosa can do it in 4 hours, and working. So this one's kind of backwards. They tell me exactly how long it takes them working together. It takes them 2 hours. This is 12 in section 13.4. Together it takes them 2 hours. Let's see, there's a larger pipe and a smaller pipe. Larger pipe can fill the tank in 3 hours less than the smaller pipe. Sort of makes sense. So how do I set that up? Normally, if they tell me that this larger pipe takes 7 hours and the smaller pipe takes 10 hours, 1 over 7 plus 1 over 10 equals 1 over x. That's how I set that problem up, right? It's the form can't change. It's just that my unknowns are now in different places. So how long does it take the smaller pipe? X. How long does it take the larger pipe then? So I'd say 1 over... Together it takes them how long? So the larger plus the smaller takes 2 hours together. So what's the larger? 1 over x minus 3. Smaller? 1 over x. There you go. See, so it's just my unknowns. Normally I don't know how long it takes for them working together. Now I don't know how long it takes for either one of them working alone. I don't know. Well, somehow I know it takes 3 hours less for the larger pipe. Right? These algebra problems kind of twist reality a bit to get them. How do I solve this? Yeah, you give everything what they're missing. This guy's missing 2x. This guy's missing
2x.
and this guy's missing x and x minus 3. So you see how your quadratic's coming out of there, right? So in this section you're expected to end up quadratic, so that either you factor it or you do quadratic formula. I can kill all the bottoms now. I don't know why, but a big problem for some reason is people forget the 3 doesn't have an x on it. And then you get really freaky answers. Like it takes this pipe -2 hours. So before it even starts, it's done. And oh, shit. Just got to think about it. I think I'll do, oh, it's done. Oh, sweet. If only. But now, of course, how do I solve that? I just have to get everything over to one side. I get like combine like terms to gas. So I got 4x. I bring it over. It gets x squared minus 7x. Add the 6 over. And that one happens to be what? What can I do with that? Can't I? Say again? You could. What's better than that?
Trial and error.
Oh, okay, sure. Trial and error method of factoring. So the main thing here is factoring. And 6 to make 7 would be. So x is 6 or x is 1. Why does it make no sense for x to be 1? It's a very strange question, but
That'd be -3 hours.
yeah. Again, then it would be -2 hours, like I said earlier. Then 2 hours before you start, it's done. That's really, really.
There's X minus 33 here.
So, do you understand? That's interesting because that's never happened to us before. 1, what's wrong with 1? You normally throw out negative answers because you have a negative side length or something. Well, 1 makes somebody not make sense. Just like if I had this in my equation, x can't be 1, right? So that's not what's happening. It makes this make no sense physically. Throw it out. So x is 6, so the smaller pipe takes 6 hours, and the larger pipe takes 3 hours. So why does that make sense?
Smaller than both.
Yeah, exactly. If they're working together, it should take less time than either one of them alone. So if you got 6 hours and 1.5 hours, you did something wrong. Somehow that smaller pipe is messing the larger pipe up. For some reason, the larger pipe is a little old man. Okay. So remember, this starts, what section does this start with? 12.8, kick ass. So there will be, you know, like division of complex numbers and all that stuff. There we go. Number 3, all that stuff there. Might ask you I to the 87th power or something like that. Okay. And then I've got completed the square, quadratic formula, right? That kind of stuff. Yeah, so if I ask you, what's I to the 397th power?
Break it down.
Break it down.
196.
So I like, some people, I like this, yeah, it's 396. 4 would go into 396. How do I know that? Because it's 4 away from 400. 4 goes into 400. Times an extra I. Well, I to the 396, by definition, is 1. Every 4th power starts over at 1 again. Done.
What's I to the third power?
Alright, so yeah, so what's I to the first is I.
-5.
I to the 0 is 1. I squared is -1. I cubed is negative I. Good. And I4 starts over again at 1. So that's why if it's remainder 0, the answer is 1. If it's remainder 1, the answer is I. so forth. Because it keeps cycling through. It's really, really nice. But some of you guys have realized you can break it down with I squared. There's a few different ways to do these problems, whatever makes the most sense. I don't think I showed you this yet. And now you'll understand especially why you have to show me some work. Let me show you how the graphing calculator can do complex numbers for you. Oh. People interested. So you guys might already know this. You guys know where your I button is. Way above the dot. Alright? So if I hit, there's I. So watch this. If I did, let's try this. What did we just do? Oh yeah. So if I do I to the 397. Well, I like that. That's awesome. It's too bad for you. I was curious what this thing would do. So the calculator does not have these rules built into it. It actually does something you're going to learn in pre-calc, for those who are taking pre-calc. It applies an interesting process, and it does that to all complex numbers. Because if I had 4 plus I to the 397th power, there's no quick way to do that, really. There is, but we don't know it. So the calculator, so it uses it even on this. So if I get this answer on the test, I'll know somebody is just taking it straight out of the field. But look what it's saying. What is negative 4.7 e negative 12? What does that mean? What's the e mean? Times 10 to the. So negative 4.7 times 10 to the negative 12. That's basically 0 for us humans, right? But the calculator, the process it uses, only got that close. This happens a lot. Like when you graph and you find a vertex and it says 2.999999996, it's probably trying to say 3. It just could only resolve it to that close, right? This calculator is not magic. It doesn't know everything. It has processes it uses, and there are limitations to those processes. If you go up to like numerical analysis, if anybody's doing a lot of math, you learn some of the algorithms that the calculators could use. So the answer really is 0 plus I. The answer is I, like we got. But now watch this. It should be able to handle this a little bit better. If I did, for example, 2 plus I squared, bam. All right, what's the problem on the test? On a practice test. There we go. If I do part E, 2I minus 7. Divided by 3I plus 1. And what I got was, let's see, it should be 2.3I minus 0.1. Yay! You guys with me? Because the actual answer I got was 23I minus 1 over 10. The calculator is always going to give it to me in A plus BI form. So it just divided 10 into both of those, broke them up. So if that answer just shows up out of nowhere in your test, that's no good. You've got to show me some work, but you can check your work. That kicks ass to know that that exists. Right? I'm curious. Watch this. Let's try this. What's the square root I? Obviously, it's that. That's awesome. So what it ends up being is root 2 over 2 plus root 2 over 2 I. Or maybe one was negative. I can't remember. Anyway, you'll learn how to do that if you take pre-calculus. If you don't, again, you're missing out on so much. All right. Thank you. Anything else we're going to talk about?
The square when it's like a negative.
Yeah, let's do it. Thank you. Yeah, sure. I don't know how ugly I want to make it. What you got?
Okay.
And they want you to put it in standard form or something, I guess?
Yeah.
Okay. So the very first thing you have to do, like you said, is what?
Negative. Oh, take out the.
Yeah, take a negative 1 out, because the first number is not 1. So take whatever is there out. Out of how much? What do I put over here?
-7.
Yeah, -7 just kind of moves over there, out of the way. I'm not thinking, don't take it out of all 3. And then I get,
X squared plus 1.
good. Change the sign, be really careful. You took a negative out. Just gotta change sign. And we've done enough of this. We don't have to do the steps, do I? I mean, what number does this need? 4. It's like if I see a 6, I know it needs a, maybe not,
36.
a 9. We don't have done that. Okay. So 4, half 4 is 2. 2 squared is 4. It needs a 4, but what do I have to put out there?
-4.
No.
Oh.
Yeah, I just did -4, didn't I?
Yeah.
So then I do have to undo that -4 by doing +4. So whatever number you take out here, it's going to affect the number that you put in there, and you have to do the opposite out here, so that you're putting the sand down there and taking the gold thing away. Right? If you haven't watched the movie, you should watch it. It's very mathematical.
Oh.
I don't know.
So it was originally supposed to be a -4 on the outside, but since there's a -1 on the outside, you just multiply this.
Yeah, if I add 4, I got to subtract 4. That's for sure true. But I didn't add 4. I subtracted 4, so I have to add 4 at the same time. Whatever I totally do here, I have to totally undo out there. So that overall, this is the same thing as this. Right? If I work this back out, I better get this. And sure enough, -1 times 4, -4 plus 4, so I'm left with -7 like I'm supposed to be, right? Just a quick check, make sure that it actually works back out. So I don't know, sometimes I wonder if math students realize every time I do something like this, equals, whatever I end up with is exactly the same as what I started with. That's what I'm saying. They are the exact same thing, they just look different. So why do we do that? Because if I finish this out, what's this?
X plus 2 squared. Minus 3.
Good, but since that is the exact same as that, if I work this out, it becomes this. So what the hell did I do this for? Because now I can see a lot of things. I can see the vertex.
X maximum amount. I would just -2.
Axis of symmetry.
Axis of symmetry. It opens,
Down.
of course I can see that before, but I won't. It opens down, so this is going to be the location of a max. Good. Range would be infinity up to -3. Okay, good. Right. Once you know the vertex, you actually know a lot of shit. Combine it with up or down, you know a lot of shit. Okay. All right.
What if it tells you put it in standard form? And like you have let's say you put -3 out there, but instead of 15x, you put a number that does not go into 3.
Oh yeah, well 15 would be kind of bad because it would leave you with 5, which you can't cut in half nicely. But yeah, let's make it even worse. Let's make it, because you never know. I'm a math teacher after all. You never know what the hell I'm going to do. So let's make it plus, let's make it really, really good. Let's make it plus 16. That's awesome. That's right. When I make this wrong, I'm like, oh yeah, so killed it. It's the same thing, right? In fact, it's only us that are worried about the process. Doesn't give a shit, right? So, out of these have to come. Right, I have to end with a 1. Now so why was this a 1 now? Because -3 divided by -3 is 1. So over here I'm going to put 16 divided by -3. So it'll be -16 x. I love it. Ooh, this is gross. But I mean, I really want you guys to understand. This process does it does it itself. It does everything itself. What do I do with -16 Multiply it by 1/2 to cut it in half. 2 goes into 16 8 times. So I get -8 And the second step is 64 over 9. And what do I do with that? Put it there. Now here's where things get a little interesting, and what you can do for yourself is, watch this, you could do this. It would have to be 3 times that, and you have to change the sign. So just put on here plus 3 times 64 over 9, and then work it out on the next step, right? Change the sign, and then just put that times that. That's what you're going to put outside. There's a lot of different ways to remember what to put out there. But it's got to be the opposite of negative 3 times that, which is positive 3 times that. So that's where they, now, how does this factor? Why is that not a hard part? That is totally not a hard part. How does it factor?
X minus 8 over 1.
X minus 8 over 3 squared. This tells you how it's going to factor. Now here I'm going to get minus 1 plus...
64 over 3.
Yeah, good. It goes in there 3 times 64 over 3.
Common denominator. Multiply the other one.
Yeah, 3 over 3. So negative 3 and 64 is 61. Look at that. That is yummy. The hardest step in that problem, well, I think for most of us was this. You've got to be careful. But just remember, when you take something out, you're dividing it out. So if it doesn't go in, you just put that over that. It didn't go in. That's why it didn't become a nice number. It became 16 divided by 3. I don't know what the hell it is. Yes?
So we always make the coefficient of x squared 1?
Yeah, before you can start completing the square, it's hardwired on this being a 1. We could have made a process that didn't care what that was, but that process would have been longer and more disgusting. So we just said, if that's not a 1, just make it a 1. And then you got a much easier, nicer process to follow. Right? And what's the vertex?
8 over 3.
Yeah, positive 8 thirds, positive 61 thirds. I mean, the hard part's over, right? It opens down, so this is a maximum. Oh, yeah, you know, all the rest of it should be wrong. What's the y-intercept? Yeah, look up there. I'm here to get you ready for tomorrow. So if you are ready for tomorrow, you don't have to be here with me. Some of you guys will look at me like, come on, let us go. I'm not holding you here. Any other questions?
I have a
You've been saving them? All right. Yes.
I know you just did it right now, but I told you about how to get the X Intercepts for number 11 again.
Oh,
No.
I think I have that in here still. So let's find the other one. Is that the one?
No.
Shit, that's the one from the book, isn't it? But let me just show you for this. I don't think it's the same function, but it's the same process. You ready? Or do you want to do it with me? I don't know.
Yeah, let me redo it then.
All right. So you got it? No? Which one was this? This was one out of the book somewhere. Oh yeah. Oh, okay, that's right. That was that one. Maybe. Good. All right. So graph. And if you make your window -3 to 3 on the x's, it'll look the same as mine. Now, here's how you find x intercepts. Second calc. X intercept hits the ground. The y-axis, the x-axis is the ground. So that's why we call it the 0. It's the starting point. So I find the 0. I happen to be closer to that one right now. So it's going to ask you 3 questions. It's going to say left bound. So you hit the left button a few times. Enter. Then you go back on top of it. Right bound. Hit the right button a few times. Enter. And the guess. You go right back on top of it. Enter. So the reason there's 3 questions is it wants to find out what's the lowest and the highest it could be, and then a guess. So then it knows to search in there.
Okay.
And again, if you go to calculus, you'll actually learn the algorithm there that it uses to figure out what the root is. And to find the other root, you do the same thing, just up there. Yeah. Kick ass. Sophia.
Okay, so this is for 13, I just need help setting up the equation. It's 13.4 number 9, and it's like an upriver and still waters.
Oh yeah.
I just want to know what equation I can do the rest.
So you know that the Hudson flows at a rate of 3 miles an hour. Which one am I going faster, upriver or downriver?
Downriver.
Downriver, good. So the Hudson's either giving me 3 miles an hour or taking 3 miles an hour away from me, right? So what's the speed in still water? Still H2O.
You would use this.
No, the Hudson is 3. What's the speed of my boat?
Plus or minus.
Do I know?
I-
No, it's X. Yeah, that's the question, right? All right. So, I got downriver. I got upriver. What's the other specifics here? Patrol boat travels 60 miles upriver and returns. So how far does it go? Each way it goes 60, right? Is that cool? 60 miles upriver and then it comes back. Total time of 9 hours. So this is where people put 9 there and 9 there. Why does that not make any sense? 2 reasons. That doesn't make any sense because that's a total of 18. And then another reason why you couldn't do this is because I'm going faster in one and slower in the other. How could they both take the same amount of time? So you can't put any specific numbers there. In fact, you can only put specific numbers in 2 of these boxes, or else there's no need for algebra. Otherwise, I know too much.
So down is going to be x minus 3 and x plus 3, and up is x plus 3.
Well, you had it right before. Upriver is
X plus 3.
slower.
Okay, sorry, minus.
Yeah, and actually here it doesn't really matter, but be careful because they might switch something else. And downriver is faster and going with the river downriver. Right. Upwind and downwind, right? Same idea.
I can't do it.
Is that good?
Yeah.
Everybody else cool with where to go from there? What could I put here now?
60 over x.
Yeah, time is distance divided by rate.
And then 60 over x minus 3.
And then these two have to do what? Careful, it didn't say in the same amount of time. It said in a total of
Those two. 9 hours.
9 hours. So this plus this equals 9. Good. So be careful. I can only make them equal if it actually says in the same amount of time or something like that. Right. The statement I make is what sets up my equation.
9 hours?
9, yeah, 9 hours. Cool. So what else?
So wait, so that's going to equal 60 over x plus 3 plus 60 over x minus 3 plus 9. Yeah.
Equals.
9.
Yeah, this time, that's what it is, right? That's the time downriver, that's the time upriver. Those times have to make 9. This isn't this guy works and this guy works and working together. It's not a working together. This is a time plus time is 9. The total time is 9 hours. This is not a working together problem. It's not that kind of a thing. And then, of course, you get LCD and so forth. All right. All right. Where else are we going?
Let's just shoot out numbers.
I just, okay.
15.1.
Okay. Can you go over,
Oh, so we're only doing up to 14 too on the test?
Yep. We'll do the rest of 14 for the final. For that quiz. The double quiz.
I was really struggling with just in general questions from 14 and 22. I really struggled with it. Maybe do a couple tonight.
Okay. Like which ones? We did some from, just the straight up composition problems. We did some from where they give you a table of values. We did some from where they ask you to find what F and G are to make it work for the composition. All right. So in 14.1, the ideas that they give us are composition of functions, right? Putting functions inside of other functions. How are you with that? Okay, that should not be a big deal. If you understand functions are just substitution, nothing major to that. The biggest mistake I always get, no matter how much I say that it isn't this, is that I'll ask somebody, what's f of g of x? And they say it's x minus 3 times x squared plus 4. And what are they thinking? They're thinking that this means multiplication, but no. It's sort of like thinking that square root of 7 means the square root times 7. No, it's the square root of 7. The 7 is inside. So this means the g is inside of f. So you would put this in there, right? Okay. That's one of the biggest mistakes. Let me see what else is weird here. I think you guys understand the one we did earlier, where they gave us, they give it to us in this form here. I say, what is f of g of 1?
So you look at a G.
Yeah, what's g of 1?
2.
2. And what's f of 2?
1.
1. Yay. Right? So we did one earlier, but I had y1 and y2. I can call these functions anything I want to. F and G, J and K, happy face and box function. Believe it or not. So I got an X, the happy face function, and the box function. I don't care what the hell symbol I use. I can use symbols that we recognize as letters. I can use symbols that we recognize as shapes. Who gives a shit? They're just different functions, right? And then I can ask you the same kind of questions.
For f of g, do you look at x, the x column? Because there's...
Yeah, this is the input for f. It doesn't matter where this 2 came from, so I understand what you mean. It came from g, so how does it suddenly become x? This just means when the input for f is 1, I get a 4 out. So they're using x. Do you see that? So these match. If that in there is 1, so what is in here? 2. So when that in there is 2, I get 1 out. So don't get too hung up. X is just kind of we very often we call them dummy variables. They're just stand-ins. So this tells me the form of f and what it does to inputs, and then I just see what my input is.
Can you go over number 31 again? When it's like you have to identify.
Oh, so if I had, 34 specifically was, so if I ask you, I just really want this to make sense. There's an inside piece and there's an outside piece. What's on the inside?
The G.
Well, what specifically is on the inside?
Oh, for x minus.
Yeah, so the G. So G is the inside piece. And what am I doing to that inside piece? I got this. Yeah, exactly. So if I put that in there, I get this. Yeah. So it's not always easy, but that's how you think about it. And you can check at the end, make sure that it makes sense. Does it work at the end? How's my camera?
How would you write that in another way?
Easily. You ready? Let's see. Let me not make it too freaky. So what if I said G, let me see, f of x is, what you got, Jeff? X minus, or plus 1, let's see if this works. To the fourth, let's make it 3x plus 1. And then g, let's say, is x minus 2. Does that work? Yes, I think so. So if I plug this in here, I get 3x minus 6 plus 1 is 3x minus 5. But do you see how that's kind of like, you know, you have to kind of work at it to make it come out to be. This is not something that just come to you. This is the one that would just come to you. There's an inside and there's an outside. End of story. But believe it or not, there are parts of math where this is the better way to write it for some reason. There's some other part of the function that's this, and it's better to write it like this for whatever reason. But that's the base function. That's the one that makes the most sense.
13,350. It's they give you 2 points, 2 minus square root 10, and then 2 plus square root.
Oh yeah, and that's the one that you just got to brute force.
I brute forced it. I just wanted to make sure I did it right.
You got to end up with only integers. Did you?
Only integers.
Only integer coefficients.
I just got like an x squared minus 4x minus 6.
Okay. And to check it, you just do the quadratic formula.
So to confirm right here, so then you FOIL that out, and then it'd be x squared, and then minus 2. Does see that? I was getting that minus 2x, and that x goes on the outside of the 10 also.
Yep, good. Yeah, you're good. Real quick, just to show you, I can make something that's a little less freaky than that is this. You guys see how that works too? If I put that in there, that squared is that to the 4th power. You guys see that? I mean, that's another acceptable answer. And then you can imagine sometimes they'll have problems like this. You need 3 functions. All right, let's think. Okay.
Number 3, 13.4.
No, 4 comes from. Oh, 4 comes from. So I have 5. And then it takes 1 hour. So 5 minus 1.
Oh yeah, good. All right. So number 3 and 13.4 sounds a little weird. Franklin's Ford travels 200 miles, averaging a certain speed. And goes 200 miles at X miles an hour. If the car had gone 10 miles an hour faster, the trip would have taken 1 hour less. Okay, so let's start making our little table here. So say normal, and we'll say faster. So normally he goes 200 miles at X miles an hour. If the car had gone 10 miles an hour faster, well, that's nice, just X plus 10. The trip would have taken 1 hour less. So he's still doing the same trip. It just takes an hour less. So that hour less is where my equation is going to come from now, right? Because I've got 2 empty boxes left. And I got 1 statement that I haven't done shit with. Okay, good. Empty boxes I fill in using this idea. So what goes here?
200 over x. 200 over x.
And then, I remember this problem. I think the trip would have taken 1 hour less. So, of course, this is the faster speed. So this should be 1 hour less than this. So whatever this is, how do I make it the same as this? This time is 1 hour less than this. So this would have taken 1 hour less than this did. That's how I translate that English statement into math. Because now I've got math representations for each time. I can put them into the English statement of how they relate to each other. One is 1 hour less than the other. And then I know how to solve that. We did one like that earlier. Of course, now that we know quadratic formula, they don't all have to always factor. You might get 2.49783 as an answer or something.
I put plus 10 instead of minus 1.
Oh, shit. All right.
Yeah.
Oh, you used the 10 twice. I got you. Because it was that related to the speed.
Right.
Okay. Okay. Wow. That's early.
Fourth of July weekend, that's probably what. Hey, you will be ready today. Yeah, same. 22 on 14, 2. It's y equals 2, and then x1 is x plus 1.
So that would take 2 to the x and move
Take
it.
backward.
Yep.
If we didn't go backward.
Is that cool? Or
No, that's cool. That's cool. I was just curious.
Shooting 42.
yep. Thank you.
For 42.
Vanilla. It would work. It would be really gross. So you use the 1. Good. Good. Let me see. Let me make sure. Be careful here. 5 plus 1, 6. Wait. No, you put it here. I see. I'm with you. But how did this become -5? That's what's throwing you off. It's -1, right? And then you can use that -1 to kill these. And then you can do this last time.
Alright, so one more time. This is the one we did earlier. So then I did second calc, and then I pushed it over to the right a couple times.
No, left down.
Oh yeah, left down. Does it matter how many times?
It really doesn't. You just want to give enough room so you can have a guess in the middle. So a few times enter, and then get right back on top, and then a few times right, enter, and then get it right on top.
Oh, and then I have to move that on top?
Oh, somehow you came out of, oh, it did it. All right, that's weird. Did it do it, or is that just,
I don't think it did it.
no, I don't think so either. Oh, what happened there? All right, try it.
Alright, so left down a couple times.
Enter, and then right of the answer, a little bit enter, and then right on top of the answer. Because it might have a problem if your guess is the same as one of the.
Yeah, see, okay, then.
It's there, it says maximum.
And then to find the x intercept, we did second calc.
Find the y intercept? Yeah.
Or 0, it doesn't.
Yeah, you're right. This is the x intercepts. Yeah.
Okay.
So then you would go same questions, right? So you go
Left.
like if you want to find this one, no. You're not finding the maximum. You're finding the intercept.
Okay.
So you want to go left of the answer for this. If you're trying to find this, right? Trying to find the x intercept, it's right there. 2 of them.
Oh yeah.
So you want to go a little left of the answer, enter. A little right of the answer, enter.
So like right there?
Sure.
And
Sure. And then right on top of the answer.
I see.
Yeah.
Science.
So that left and right thing is just giving it an area to search in. So it knows.
When I was doing the second right one, I wasn't moving it back towards the middle.
Oh shit! So it's giving you some kind of error, right?
Yeah, exactly.